Hey guys, it's Miss Blake here. We're going to move into section 1.2 on linear equations. So definition of linear equation can be written in the form ax plus b equals 0, where a and b have to be real numbers, a cannot equal 0. So the first example is solve and check. So we're going to solve for the value of x. We're going to subtract 5 from both sides. So over here you're left with 4x. 29 minus 5 gives me 24. Last step, divide both sides by 4, and you get x equals 6. So that was the solve. Now to check, you're going to plug that value in and make sure it actually works. So we're going to say 4x plus 5 equals 29. And we're going to go ahead and plug in our value of 6. So 4 times 6 plus 5 should equal 29. So we got 24 plus 5. And you get 29 equals 29, which tells us that our answer did check out. So there's 3 different types of ways an equation can work out. The first way is called an identity, and a good example is where you can plug in any value for x and it will still be true. So over here you have x plus 3 equals x plus 2 plus 1. If you went ahead and combined terms on the right side, you got x plus 3 equals x plus 3. When is that going to happen? Always. So that's an identity. You can plug in whatever value for x. X is actually going to be, all real numbers. So that would be all, there it goes. All real numbers. Good. Every number will be plugged in there. The next is a conditional. This is what you're used to. This is going to be true for one real number. So a good example, 2x plus 3 equals 17. Subtract 3 from both sides. 2x equals 14. And x equals 7. So that is considered a conditional equation. Again, under that condition that x equals 7, this is considered to be true. And then the last one is inconsistent. You might have learned this as no solution. And a good example of that, x equals x plus 7. Notice what happens here. If I subtract x from both sides, I'm going to be left with 0 equals 7. When does 0 equal 7? Never, right? That is not true. So before you might have written this as no solution. Same concept. We call it an inconsistent equation. It's not going to work. So that one's not going to work out for you. So again, we have an identity. Identity is when all numbers work. So if you notice here, if you went and solved this one, subtracting x from both sides, you get 3 equals 3, or even 0 if you subtracted 3 from both sides, 0 equals 0. If you get something that's always true, you're going to have that identity where you can plug in any real number. The conditional, again, is where you only get one answer, so it is true under that one condition, in this case x equals 7. And then inconsistent is where it's never going to be true. Those were those no solutions you learned. So let's try a couple of examples. So this first one, we're going to keep this side 4x minus 7. We're going to go ahead and distribute 4 times x, 4x, 4 times negative 1, negative 4, and then that plus 3 on the end. We're going to do some combining like terms, 4x minus 7, and then 4x, and you have a minus 4 and a plus 3. So you got minus 1. And we're going to bring that over here. 4x minus 7 equals 4x minus 1. Let's subtract 4x's from both sides. And you got negative 7 equals negative 1. And I feel like we should be able to stop there and see that negative 7 is never going to equal negative 1. So again, that was that no solution, or as we just learned it, inconsistent. Right, -7 is never going to equal -1. Moving on to the next example, 7x plus 9. We're going to distribute 9 times x and 9 times 1 and drop down that minus 2x. Again, we're going to combine our like terms. So over here you got 9x's minus 2x's, gives me 7x plus 9. And notice you have the same thing on both sides. If you want to, you could keep going. I'm hoping you realize here that it's an identity, it's the same thing on both sides. But if you kept going, subtract 7x, you'll get 9 equals 9. When is that going to happen? That's always going to happen. So this is one of those identities where you're allowed to plug in any value for x and it's always going to work. So that's called an identity, right? And we could plug in all real numbers and it would still hold true. All right, that's it for today. You guys have a great day and get your homework done.